Right, off you go, Tom.
Okay, good. Yeah, I can see it. All right, I pulled this together in a couple hours this morning from previous PowerPoints I've done, one going back to 2009. So
Hmm.
you can go to the next slide. I use the term coherent modeling for this style of modeling that I've developed, but there's nothing official about it. So this is first of a number of slides on the model architecture, which I think is very important to understand. And if you look at the right, there's a quote model element, which has semantic properties. This is a term that my modeling tool uses. I'm not sure whether UML uses it or not. I don't think they do. On the left, there's a diagram element, which visually represents the model element, and it has appearance property. And it's part of a model diagram. And I used to just call it a diagram, but I wanted to make clear the distinction between this diagram, this type of diagram, and any run-of-the-mill diagram, which is just, I think of as a sketch.
Yeah.
Because this is showing a subset of model elements. A subset is it's showing diagrams elements which represent a subset of model elements. So it's a different kind of diagram. So I call it a model diagram. Okay, going to the next one. So I think of these as two different subsystems. The one on the right is a semantic subsystem or definition subsystem. The one on the left is display, or actually I prefer a presentation subsystem at this point. So next slide, please. So this just emphasizes that the model is made up of the two subsystems and are relatively independent except for that one visually represents link. All right, next one. So all the semantics are in the semantic subsystem. And if you click one more time, things like name and so on. And if you click again, all the appearance is defined in the presentation subsystem. So they're minimally coupled. They're almost completely decoupled as much as they can be, but you still have to have a representation link across. So go on to the next one, please. So these are all in the modeling tool. And next one. Okay, so this is sort of an example. You do a model diagram, you create some diagram elements. In this case, I think this was an example when I was working for an insurance company. You have a subscriber and an affiliation with a plan sponsor. So within the modeling tool, it's often called the repository, these definitions reside. So you can see there's a plan sponsor, has a name and a link to a subscriber, and then the subscriber. And then on the right, I wanted to show that each one of these elements, including links, processes, states, transitions, every possible UML element, has a documentation slot, so it can be defined textually. Now, I think it's preferable to define it in the model, but in some cases you do need text, and it's very useful to do. You can display the documentation on the diagram or not. If I drag the documentation to the diagram, it would show the text and link it to whichever element it's related to. Okay, next, please. All right, so this is diagram 2, and it's showing the same semantic elements, but it's showing them with different diagram elements. So they're in a different orientation, they're different color, different font, and most importantly, they have additional information. So you can control how much information you have with each element. Next, please. So this is just emphasizing, this is a little bit redundant, I guess, just emphasizing that the diagram element shows what you see and the model element defines what it means. All right, next, please. So this tool architecture enables multiple views with only single definitions, which is a really key thing. Next, please. And I'm showing an example here with the classic engineering drawing, which in my experience is three views, but this is 6 views. If you do another click, please. And another one. So it shows how you can take 3 dimensions and show it in projections of 2 dimensions, which is pretty standard. All right, next, please. So you can think of these as projections. You have a 3D object and it's projected into 3 other views. Next, please. This can be extended to any length. You can have as many views, show as many dimensions as you need. So it's very has great potential, but you need the kind of architecture that I just showed to be able to do this. Otherwise, you can't possibly manage all these diagrams if they each have their elements defined separately. But when they're only defined in one place, you can manage the definition and then you can show it in different ways. So I see huge potential here that's not normally leveraged, because you need a certain way to do it. You need a modeling tool and you need to understand the ability, the capability to do it. So next, please. So there's 2 typical uses you're probably familiar with, although they have different names. One's I call levels of abstraction, where you trade off scope and detail. So you have a hierarchy of views. At the top, you have the entire scope, but you have to have less detail because there's not room to put all the detail. Now, you've probably seen some diagrams where they try to put all the detail into one diagram, and it gets past the point where it's not understandable. I have a couple of examples of those. This is especially important for systems where you need to see the big picture of the whole thing. Then at the bottom of the hierarchy, you have full detail, but reduced scope. So you have to have multiple diagrams there. And then you can have multiple intermediate diagrams that traded off at scope and detail different ways. So the poster boy for this is like Google Maps, where you can zoom in to any detail, well, not to any detail, but to quite a lot of detail, and you can zoom out to get the big picture. So I think of that as a leveled model. And that's important to be able to do that for systems. And the other way is you can show different perspectives. And I guess the example I think of for this is if you do a building and you have a structural aspect, and then you have electrical aspect and a plumbing aspect and a air conditioning and vent aspect. And you might not want to show all of those at one time, but you probably want to show the structural version in each of the other ones to show how that fits into the structure. And maybe you want to show them all. So you can do different perspectives and show the aspects individually or in some combination. And the first one's often called vertical abstraction and the second one horizontal abstraction. So my point is that you can create as many views as necessary for understandability and critical review. So if this is going to be a so-called perfectible model, one that you can continuously improve, you have to, all the reviewers have to be able to understand it and review it and make suggestions. So I think the presentation aspect requires a lot more attention and effort than it's given now. Next slide, please. So this is the last slide. Conclusions. Domain of any scope and complexity can be modeled given sufficient time. I mean, it can be done, but it takes time and energy. A perfectible modeling process can be established where you never reach perfection, but you continue to improve. You get closer and closer to your ideal. And this is best described, I don't know whether it's developed, but best described by Acuff. Knowledge fragments can be integrated and unified. And that's the big bugaboo for systems, of course, is, well, there's tons of information, tons of knowledge, but it's all fragmented. It's in different languages. So this is a way that it can be put together. Again, it takes time to do it, but it can be done. So I see this as making it possible for the system-oriented universe to be modeled and better understood. I don't really see how you can do it any other way. There may be other ways, but I can't imagine them. So that's why I guess I'm so attached to this and why I've been working in this direction. So that's it. Sorry, it's sort of short and sweet, but so I'm not saying anything specifically about the models that we've been talking about, except that I try to follow this. And I think they are both perfectible in that the definitions are non-redundant. The whole semantic subsystem is managed to be non-redundant. So everything's only defined one time and it can be changed. Everything can be changed just by changing that one place. And the tool will automatically change it in the diagrams. Diagrams may need a little cosmetic attention. But other than that, it can be done. And that's a huge capability. And it causes you to proceed in a whole different way, knowing that you can change things. So you don't have to worry too much about names. For example, they're relatively simple, but let's call it XYZ for now. When we understand it better, we'll change the name to something else. And so it can continue to be changed over time. And it ends up being a little bit like brainstorming. When you're working with other people, say, well, let's call it this way, let's show it this way. And then you say, well, now that I see it that way, I understand something else. So let's change that. And one of the sort of radical examples of this I've seen is when a model is initially established and some new information comes in, it's usually, quote, tacked on. In other words, you maintain the existing model because that's already in place and it's hard to change. So you just add the new stuff on. But if you can easily change the model, you evaluate the existing data and the new data, you decide the best way it all should be connected or organized, and then you change your organization if necessary. That seems like a huge difference in thinking from examples I've had in industry. One of which was a company that decided to have a database for people, and it was going to cover employees, clients, all people of all different types, which is a very good idea. But they already had in progress a development offshore that was going to use this. So we had to focus on that first, on support for the project that was already going. And so it got oriented towards that. And then once that was in place, you couldn't change that part. So as we learned all the rest of it, we were forever oriented towards the first application rather than making it general the way it should be. And I see that that happens a lot of places. So it's a whole different way of thinking when you can actually change anything in a model. That's my spiel. And I'm going to stick with it.
That's good. The story sounds familiar.
Yeah, I'm sure.
Hmm.
So I was thinking of when I said I was going to look at modeling the application. In fact, somebody suggested that to show more details of the application, and I can do that. I have some sketches that I've done in the past, but I thought this was more important to show first. And it applies to both systems common and the system types model, but they're separate individual models. But I both tried to follow this, which I sometimes call coherent modeling.
Hmm. Do you have any thoughts, Bruce? You're on mute. You're muted. You're muted, Bruce.
Sorry.
It's all right.
No, I think that demonstrates the power of modeling. So, and that's one of the key features that's being pushed in model-based systems engineering. So one source of definitions and used many times. That's very important.
I assume it's being done a number of places with modeling, with the modern modeling tools that provide that capability. But on the other hand, I modeled for a number of times with a tool that had the capability before I realized the importance of it.
Yeah.
So I assume there's a lot of people that don't understand the importance of it. And a lot of people think a model is a sketch of a diagram. And it's completely different.
Nope.
I get a lot of feedback. Well, I originally started modeling UML in PowerPoint. And the amount of people who told me, no, you just don't do UML in PowerPoint. You need the repository behind it. So yeah. I've had my, I learned my lesson the hard way because people started refusing to look at PowerPoint.
Yeah.
Because the people that I was working with, they knew that it didn't have a repository behind it. So there's, it's a fairly important aspect. But there are lots of tools that have that repository.
Yeah, I would think most modern modeling tools do have that capability.
Yeah.
I know the few other ones I'm familiar with do to some degree. So I see a lot of potential to doing the presentation part that's not done. And that's one of the things I think we should consider for going forward with the systems common is that there's a lot of basic data in there, but there's potential for associations between them that is not done yet. In some cases, there's some examples that I've done, but didn't have time to, or for some reason did not go as far as I could with it. And a lot of cases I think exist that haven't thought about. So thinking that systems really you should, and after reading Capra, which I've been doing, think of it not as a system, not as things, but as relationships. It's the relationships, a lot of the things are there. It's the relationships that can easily be added now. But you have to imagine what it is you're trying to show and how the best way to do that.
Yep, great.
So that's sort of what gets me up in the morning because I see all this potential and I'm just very anxious to come up with it. And it's time consuming. Doesn't go as quickly as you might think. I keep thinking of the saying about your reach is greater than your grasp or whatever. Like keep chasing all these different things. Don't really get a hold of too many of them.
Yeah. But it comes back to essentially providing enabling constraints and an orientation for people to work within a framework. Yeah.
Yes.
So
Yes.
that we can delegate the definition of the model to many contributors. Yeah, because no one person can do it on their own because it's just too big.
Yeah. Yeah, absolutely. I think of it as a model-based collaboration.
Yeah.
So when you agree or you come up with some new information or whatever, you can put it in a model and now it's there. You don't have to do it again. Now, if it's easily changeable, it can get changed, and that's fine. Over time, you get it to where people agree,
Yeah.
or if there are disagreements, you can actually capture the disagreements and have alternate ways. And I don't see anything wrong with that. In fact, it's probably necessary. But we go, and just about everybody else goes round and round and round, and some of it ends up being in a book several years later. But
Yeah.
the collaboration, the cycle time is way too slow. So the real question in my mind is, what's the best thing to do at this point? There's a lot of options.
Well, I've got an idea. If you're interested. So I've been trying to create this sort of like meta framework for knowledge about systems and also knowledge for how we engage with systems.
Yes.
I've produced essentially a conceptualization. It's essentially an informal model. Yeah. The next logical step would be to take that conceptualization and start to formalize it in terms of the entities and the relationships across those entities. And then we can create viewpoints from all of that stuff, and we can potentially allocate people to start populating the structures with data. Either, and including links to remote sources.
Now, do you see that overlapping systems common? The people and documents and organizations.
Yeah. So
quotations.
I think all of the data that you have within an awful lot. In fact, all of the data you have in systems commons would fit there somewhere. Yeah. And it might well be that by looking at systems commons and what you've got there, we may identify some additional entities that we haven't taken into account.
Yes. Yes, the other thing that I thought of showing you, but I didn't get it into the PowerPoint, was the quote types model that I have in the system types.
Yeah.
And that's the class model that everything else are instances of. So there's person, there's document, there's a authored by relationship between the two, and so on. And everything, including all the relationships, are instances of that. It's in effect the schema of the database. So if you need something else, you can define a new class and whatever relationships it has to the other classes, and then you can create instances of it in diagrams. So it's relatively again, adaptable. It can be changed, but it takes some forethought and some knowledge and some planning to actually do it. You can't just let everybody change the schema.
Yeah, yeah, completely agree.
And often there's trade-offs. You have to think, well, if we do it this way, you can do this, but not that. If you do it that, so you have to go through that process. And it ultimately depends on what you're trying to achieve. So it's what I have is sort of grown like Topsy. I started very simple, and then I realized I needed something else, and I would add something else in relationships. Occasionally I would change the names or whatever. So it could probably benefit from being reviewed. And if you were looking at doing some capabilities that I don't have, then how it could be adapted to that.
Yeah.
Now, there's a possibility of just doing a whole, as I showed, the semantic subsystem and the presentation subsystem are very much decoupled. So you could do a whole new presentation subsystem, making use of the existing semantic subsystem. In
Yes.
other words, you could do your own user interface to it. So that's one possible way to proceed. I might have mentioned before that if people knew how to model or had the modeling tool, they could define their own part of a presentation that leverages the existing presentation. And then at some point it could be, quote, elevated. Parts or all of it could be updated to the common part. So you'd have a single common part and multiple individual ones. So people could put their own stuff in, but leverage. It's a little bit like what we do, what the model does now with Wikipedia. Although it would probably be coupled a little more tightly, but you could just reference existing things.
Hmm.
So I often think about all the benefits that Wikipedia provides and how I'm leveraging them by linking to Wikipedia. So that's sort of a general model of leveraging existing stuff, not having to redo it.
Yeah.
I'm happy to give modeling your model a try. I might
So
learn more from the model by doing that.
Gary, would it be worthwhile trying to define better what you want to achieve with your model and see how that relates to the existing models and whether it would make sense to tie them together somehow?
I think so. Shall I show you what we've been doing again? Do you want me to
Sure.
do it? Right. Let's start off with this first. Probably best start off with this. Yeah. So this is essentially a representation of relational theory. Yeah. So things are a source and a sink of signals and data. Yeah. So information is data with meaning. Yeah. So when the data is received by an entity, it's given meaning.
Mm-hmm.
Yeah. And that that information which is received then is structured in some way, yeah, either conceptually or physically. And what this essentially explains is that every single thing, every single system is essentially a representation of knowledge. You know, within its structure, it is essentially structured information, because everything is made up of information, you know, from the quantum level upwards. Yeah. So things are a source and sink of data. Data can become information when it's given a semantic meaning. That information can then be structured, and then that organized information can then result in forces that provide organizing constraints on energy and mass to create material things. And those things are then a source and sink of signals and data. So every single spin of this holon can create increasing levels of complexity of systems, increasing levels of complexity of things.
It's reminding me of the DIKW pyramid.
It is, yeah. Only there's an additional step, which is intelligence, which is know how. Yeah. So you've got data, information, know what, know how, and then you could relate this to wisdom. Yeah. So it does fit, and this is from Capra, and again I think it's more than a similarity. Yeah. So you've got the whole. Yeah.
Yeah.
That whole can establish a meaning based on information. It can then take a form, which is a pattern of organization. There's an ongoing process, which is the forces that provide enabling constraints on its material structure. And we see this pattern across a whole set of different frameworks, like ODA, for instance, observe, orient, decide, and act, the Kinefin framework, and Panarchy, and all sorts of stuff, because this is essentially a fundamental aspect of everything, you know, from quarks up to culture.
Yeah. Yeah, I like that. It's about putting things together, getting a bigger context to get better understanding.
Yeah.
And it seems like that's exactly what we want to do for systems.
Yeah.
But it's hard to do because, as you said, it gets more complex at each level. You know, more and more things to do.
Yeah, but it's also fundamentally the same. So and there's an example of this with science itself. Science is again a system. Yeah, and these are the 5 elements. There's ideas, which is where information is given semantic meaning. These then build our organized structures of information, which are frameworks. Yeah. And these frameworks are essentially built up from increasingly specific and comprehensive theories. Yeah. Within those frameworks, these frameworks then provide orientation for our principles. Yeah. So these are essentially the forces that we apply to create our assets. Yeah. So these would be design principles, for instance. We can use those to create our assets. And then those assets are deployed in nature and society. So again, we've got information, know what, know how. We've got the things we create, which then go into nature and society, which create more information. So this is, so working up from relational theory, we've now got these essentially 5 stages of knowledge development, with the, you know, the theories and the conceptualization over this end, and over this end we've got our practices and our assets engaging with nature and society. So that's an important dimension of the integrative framework. That, you know, those 5 columns essentially. Now, what we've also done, Tom, is we've taken fit, form, and function as a way of orientating different types, different categories of knowledge about systems and things. Yeah. So form comprises identity and the togetherness of things, and the behavior and the relationships of those things. Yeah. So this is the form, you know, the part within the whole. Yeah. Now the fitness of the part is judged by the whole, the value and the qualities of things, and the consciousness and the experience of things. These are related to the whole. And then between the part and the whole, the function is determined of the part. And the function changes throughout a life cycle, because, you know, there's a continuous process in place with parts coming into being and parts essentially dying. And the capability, the purpose of the things is essentially an agreement between the part and the whole. And we're able to relate these 6 different categories to classical philosophy. And this is the work that David Rousseau and others have been doing. So I've changed, so they originally said character related to metaphysics, and I've changed that to behavior, because behavior is, as we know, an important concept for systems. They had learning related to epistemology, but I've changed that to experience, because not every system learns, but every system has an experience and also a consciousness, an awareness of its surroundings. So what we're able to do now is, okay, so this is the column related to the concepts and the ideas and things that are given semantic meaning. So these are the concepts now placed within these particular categories. So when we talk about identity and the togetherness of things, we're talking about, we use these concepts and others: structure, components, boundary, boundedness, form, wholeness, integrity, network, topology, holarchy. These all relate to the identity and the togetherness of things. These concepts here relate to the behavior and the relationships of things. These are concepts related to cycles, to capabilities and the purpose of things, the value of things, and consciousness and the experience of things. So this is a way of clustering and capturing all of these different concepts in a way that they can be related together. Then this column would be essentially the placeholder and the area where we store theories about identity and togetherness. So for instance, our periodic table or our organized system types, that model would go here. Yeah, because this is our understanding of the identity and the togetherness of things. So this would be our equivalent of the periodic table here. Theories of behavior and relationships would find their place here. Theories of cycles and phases, of capability and purpose, value and qualities, theories of consciousness and experience. This is where those theories and those frameworks would go within this overall meta framework. So the viable system model, for instance, that would most likely fit here because it's about the capabilities and purposes of systems within a viable whole. Yeah. So what I'm showing here is not a general systems theory. It's a way of capturing our knowledge about systems. From these frameworks, we would be able to derive principles, and here are some examples. But the idea is that all of our principles related to identity and togetherness would go in here. And when these principles are applied, this would be the assets that would result. So this would be a place of storing all our system assets in terms of things. This is where we would place our repository of our understanding of processes, of empowerment, our abilities, our achievements, and our wisdom. So the intersection of the assets for acting and consciousness would essentially be a repository of our wisdom. And then this column relates to the context of the whole. So here we have domain, and what we might put here, for instance, would be this would be where we would, for instance, record or have a repository for all of our different specialisms. You know, so systems engineering would be a domain. Project management would be a domain. So, you know, that's how we would structure our knowledge about systems.
So are those assets? Is that what you're saying?
Yeah, this is where we would store the assets. So these would be assets for actually acting. So I don't know, methods. I guess, could we put methods here under processes?
Well, where did you put project management?
Project management I'd put here, you know, as a domain, as a discipline. I'd put project management here. You know,
Where, I can't see. Where was that?
In domain here.
I can't see where your cursor is.
Oh, it's at the intersection of the whole and identity.
The whole and identity up here.
Yeah.
The whole. Where's the whole? Is that the last one?
Far
Yeah,
right.
it's the far right. It's red.
Yeah, I have your faces covering it.
Oh dear.
Yeah, mine
Well,
too.
that's why.
There it is. Okay, got it. Now I see where it was. It was being hidden.
Mm. Yeah.
I always thought project management was a process. This is where you start getting into some very interesting
Yes.
relationships there.
Well, project management. I mean, that's the thing. There are of course relationships across these different data types, but project management as a discipline would go into the whole. But there would also be processes associated with project management,
Yeah.
which would
Yeah.
go into the assets.
Okay.
Yeah. So what this is showing is, you know, I guess this is what you would call the ontology. This is the essential structure. What you then need to do is look at the relationships across those.
Well, I'll just give you one piece of feedback and thing that I've been struggling with these diagrams.
Mm.
First of all, I like this diagram, but I have trouble because of the exact domain and processes and these differences. One of the things that has been coming up when I keep going through this is I keep saying, well, what's the context? And is the context a bigger integrator than having all these headings? So for example, project management and the domain fit together in the context of something. And then you don't have to go any further than that because it doesn't ever go out of that context.
Hmm.
See what I mean? So I keep hearing people talk about context as being very important. But having a fragmented model that is too fragmented and loses the context, I think could be difficult to use
Yeah.
and difficult to
Yeah.
bring together.
Yeah. Yeah. Well, this is also, I mean, I don't have all of the answers. I'm glad I don't. but this is intended to be a matrix for understanding our. This is our knowledge about systems. So maybe project management isn't here. Maybe what should be here is chemistry and physics, and biology. I don't know. Yeah.
Well, those, again, it goes back to getting the definition of what a domain is.
Yeah.
And even the definition of what a reaction is, or cost, things like that. They're very important to see how they kind of play together.
Yeah.
And there may be a context which is more appropriate. Like, for example, when I think of chemistry and physics and things like that, you have a knowledge, but you also find them in educational institutions. And it could be that may be a better context, but where does that show up? It's kind of, and the educational institution would be a system that uses it, and then there would be the disciplines that would be using it. Trying to fit it into a model like this, you end up getting, now maybe I can rethink it when you have views. It may be that what you want is a project management view across all of this information. But maybe it's different than that. So it's a question of, a lot of this is a question of how you use it and how you'd want to find it. So it goes back to the stakeholders' view of that. If I want to find project management, there are places I go to find project management. But I wouldn't necessarily, it's interesting to think about where it would be sitting next to and why it would be sitting next to or how it would be viewed. So I think these are the things that go through my head when I see a table like this, because I try and put things in it and I go, it doesn't quite fit there. So it's getting some real examples of this and how that would go across it. And as you know, and I won't go on about this, but I've been trying to focus on systems and context. And that seems like a really simple way of kind of bringing out the knowledge about those systems and the context, which is a simpler matrix.
Yeah.
So I don't know how to explain that, but it's that kind of thing I'm struggling with.
Yeah.
When I go through all the models that you've put together, and the model, for example, with Fritjof, every time I look at it, I see his concept of a system, which aligns with your categories on the left. But I don't see it fitting anywhere else in that. So it's kind of, it's how I'm struggling with the representation you've got. I understand where it came from, and I understand how it works. But now it's trying to use it, I get, oh. And to me, the top part of it is kind of like a process. You'd normally take a set of concepts, you'd get a framework, you'd then have some you'd have principles associated with the framework, you'd have assets, which you then implement into the whole context or society. So I kind of see it as a life cycle, but then it doesn't fit as a life cycle in the knowledge sense. I am trying to work through this. I will, the light bulb will go off at some point. And I'll go,
I think so.
got it.
Yeah, yeah. Oh,
There's a lot of thinking that's gone into this, so I don't,
Yeah,
it's, a huge amount of thinking. A lot of models are being brought together, which I think is wonderful.
mm,
But then I go, well, how can I use it? And
yeah, yeah,
what am I, and would I find things in that kind of knowledge repository?
yeah.
Unless you have Google search and you just go project management and it goes, "Wheep."
Mm, yeah, yeah, yeah.
So I don't know.
No, this is it's tricky. It's mind twisty. I mean, the other thing to bear in mind is that this is supposed to be, the meta science, the general science. So maybe, I mean, what's going through my mind is, in terms of general systems, general systems knowledge, what if we were to interpret resources, what would that be in the context of knowledge about systems from a general perspective?
You say again, it's the words, and I
Yeah,
look at
I know.
identity and I go, oh, the identity and resources don't quite fit for me. But
Well, these are the things.
they're the things. I don't know
They're
what
the
this.
things. They're
Oh.
everything.
Then why isn't it called things? It's it's kind of
Yeah, it could
it's,
be.
but it's the definition. It's the meaning.
Yeah.
And we talked about meaning in the semantic side
Mm,
of Tom's presentation, and it's
yeah.
getting everybody understanding the meaning in the context of what you're saying.
Mm,
And that's where, my context has come from the program and project management, and resources mean very specific things.
mm,
And I go, okay. So I have to unlearn my context to get into this context. And that's part of the challenge that I'm having. So I'm just sharing my trying to use this
mm,
and how I take examples and how I come up with, and then when you layer all the other things on it, it gets much more complicated for me because it doesn't all necessarily fit together.
mm, mm.
And that's the problem I'm having with it. I know what you've done. I think it's really quite amazing what you've done. So that's not the problem. It's how I get value out of it
Yeah.
and how I relate to it and put some examples together.
Mm,
And that's kind of the situation. That's why, it maybe putting some examples together related to, just to give you an idea, these top things came from one model. The things on the left have come from another set of models. And again, my interpretation of just the headings is different from what you've got.
mm.
I interpret it differently. So you just have to realize that I come from, a very practical, pragmatic place. And I keep thinking, how can I explain this to the people I'm working with
Mm,
and not confuse them?
mm. Yeah.
And I kind of go, whoops, I have a problem with that.
Yeah.
So I'm trying to find a simplified version of how systems work and systems knowledge that is relevant to the people who I'd be talking with about that knowledge in the context of whatever we're looking at.
Yeah.
These are the kind of things that I keep struggling with because I'm, I've worked with enough teams. I know you have. They need simple frameworks and simple models
Mm,
that allow them to go, oh yeah, I get it.
yeah.
That makes sense. So that's where I'm coming from.
Mm.
And I've been reading through your slides and your diagrams, and I haven't sent about 3 emails. So, and I keep saying, no, I can't do that. I can't say that. I've even stripped down your slide set so I can start commenting on the slides, but I
Yeah.
haven't, it's been quite a challenge, but I come from a different place, I think.
Mm.
And I don't know how I ended up here, but that's how I came. But I understand what you're doing. Don't get me wrong. I understand the left part. I understand the top part. I can
Yeah.
read all the words in the middle.
Yeah.
I may not have the same meanings as you do,
Mm.
but I understand what they're trying to do.
Mm.
So it's kind of an interesting it's an interesting challenge. It's really you've given me a lot of contemplation.
Mm. Mm.
Hopefully that's useful feedback, but
No, it
I
is.
don't
Yeah.
know.
Yeah. No.
Where do you see this going? Do you see it being populated with examples or instances?
Yeah. No, that's the whole idea. It's a way of organizing our knowledge. This particular diagram, I'm aiming, this would be a way of organizing our knowledge about systems.
Mhm.
Yeah.
Yeah.
There's then I start to integrate our knowledge of engaging with systems, as an overlay. So the first overlay is to overlay it with our transformational powers. Yeah. So this is what Bill refers to in terms of transformational powers. And the power down this quadrant is spirit living. It's about belonging, having a sense of nature. It's that being at one with the universe. Yeah, that's down here. There's that power. Yeah. So this is the tree hugging power down here. There's the power of philosophy, which is understanding your place and purpose. There's the power of theory and the theoretical. There's the technical power, the power of action intention. So this is drawing on resources and processing and the understanding of things like simpler things combine into more complex things, and very different things do many things in the same fashion. So this power here addresses limited choices and the resource and energy gap. That's what's going on here. So what we've done is we've mapped on all of, well, lots and lots of different heuristics of systems thinking, systems acting onto this overlay, and what we're then able, and that's all been done with Kumo, but what we're then able to do is we're able to give names to these pathways which essentially address the pathologies. So confusion in complexity is addressed with two pathways. One is generating hypotheses, which draws on the power of theory, and the other one is exploring potential, which draws on the power of the technical. So these are the positive pathways, which are an overlay on top of this. Yeah, so you think of it like a sandwich with the pathologies and the pathways as the glue in the center, or the strawberry jam, if you like. Yeah. So
Wow, that's a lot of stuff.
yeah, so as well as the positive pathways, we've also got the negative pathways. So manipulation of research by funders promotes confusion in complexity. Jumping to technological conclusions also promotes confusion in complexity. So these are all of the negative powers and the abuses of powers, if you like. Yeah. So again, that's an overlay. And what we're then able to start, and the Tao, the Tao Te Ching, and all sorts of different things can be overlaid. Personality traits can be overlaid onto the framework. So this is how personality traits contribute to these pathways. And the reason why I think we have all of these different character traits is because as a society we have to engage with systems, and people have different there's the diversity, the value of diversity and unity, bringing teams together, different perspectives. So this is all part of this, Carl Jung's archetypes and all that sort of stuff. Yeah, they'll be in team roles, that overlap lays onto it. There's all sorts of stuff. Systems engineering processes can be overlaid onto this as well, in terms of this framework of engaging with systems.
So you've updated your slides.
This is largely what I presented a few months ago at the ISSS session.
Okay.
Yeah. I have done a little bit. I have done a little bit of update. So this is realizing the power of systems thinking and engineering, and what I've got. I explained basically the problem with this one. The impact of complexity and confusion in projects. Yeah. The reason why programs and projects fail is poor organizational project management practices, poorly defined or missing project objectives, inefficient project planning. So it's this disorganization that's actually our problem. This is why projects fail. And as the complexity increases, the likelihood of failure increases. And there's all sorts of reasons for this, but it's essentially insufficient appreciation of the required complexity and our ability to organize towards these complex problems. And it all relates back to this. Yeah. So traditional project management is pretty good at dealing with the complicated, but it's insufficient to deal with complexity and perceived chaos. In order to be able to start doing traditional project management, we've got to lay the foundations first. We've got to conceptualize, we've got to architect, and then once we've done the architecture, then we can start doing the project. So systems of systems, really complex systems engineering. It's all over this space. It's the forming of ideas, the building of our architectural frameworks for these complex projects, which we can then put into place. But part of the problem is that no one wants to fund this part. Before the contract award, this is where all of the real systems engineering takes place. Once you've defined the scope and the product breakdown structure and the work breakdown structure and everything is organized, the project can really start. If you start without those essentials being in place, you're going to end up with huge technical debt and a horrible project. And I've experienced quite a few of those. It's not fun.
And I've experienced the opposite, because we had a process that had multiple stages before getting to that commit point.
Yeah, and that's
So
good. That's the right way of doing it.
The problem then, the problem there is not that we don't know how to do it, is that we don't know how to put it into the practices and have it implemented.
Yeah.
And there are a lot of projects, and I think I've mentioned this, I go into organizations and I say, well, hey, do you guys know Prince 2? Everybody raises their hand. They say, I've got the certificate.
Yeah. Do you apply it?
And then nobody uses it.
Yeah.
And you go, well, if nobody uses it, it's a waste of money.
Yeah, that's right.
So where does that show up on the model? So, I mean, there's a lot of practical things that this is what I mean. The context for that kind of thing, and that kind of conclusion have to be relevant to the problem that you see. Yeah. And I think we've got lots of things that fit in the context of an enterprise rolling out processes and making changes. And there are many, many reasons for project failing.
Yeah.
People in the wrong place with the wrong skills.
Yeah.
It's kind of very practical kind of things.
Yeah.
Not complex, not rocket science, but good management practice. So it's kind of, that's why I look at a lot of these things and seeing them all put in the same context causes me, my brain to go, well, that's not quite the way I see it. But
Yeah, yeah,
then that's the problems. But I understand what you've got, and I understand how you put it together. And I go, that's fine. I just have difficulty kind of rationalizing my brain.
yeah, yeah. Well, if you think of it, if you think of a project right at that very beginning, yeah, when an opportunity is identified, yeah, the things in red I believe these are the things that are basically these are the pathologies that that stall the right things being done at the right time. Yeah. So reluctance to change, manipulation of relationships, complacency, belief in unrestrained growth, competition over collaboration, lacking authenticity and empathy, and belief in a separate I.
So I go back again and say, well, what system is that part of? And it's basically an organization and teams and managers. And so, it's got a context where all of that is absolutely meaningful. That's all I've been saying is that if you can put that in the context of an organization and have that conversation about organizational issues, that's fine.
Yeah.
But that context,
well, the context is perceived chaos.
No.
And the kind of thin model.
No. I think it's more this is just me. Those types of issues are more relevant to an organization, and an organization as a system can be in any one of those four conditions. It can be there because the managers are terrible.
Yes.
They have no idea. The teams are organized incorrectly. All those practical things.
Yes. I agree with you.
Is this what you would like to model in some way?
Yeah. So this all relates back to, that more simple diagram.
Yeah.
Of it's if I go back to this, so we've got the knowledge about systems. So that's the bottom layer of the bread. Yeah. This is the jam. Yeah. So there's a model that relates knowledge about systems and knowledge about how we engage with systems. Yeah. So these are the two bits on top, bits of bread on top. Yeah. So there's positive pathways and negative pathways.
So it's relatively easy to group already existing items in the model. And I've experimented with a couple ways of doing that. One is fields, which are sort of like disciplines. So systems biology, for example.
Yeah.
And I have people and documents and organizations that are related to systems biology.
Yeah.
And I have another one, which I've called themes, which are specific problems or focuses across multiple disciplines. And then I group in the same way.
Yeah.
And they're just ones I've experimented with, but it seems to make sense. So any of your categories, if you're interested in any of the items that are in Systems Common, they can easily be put in.
Well, that's what I'm hoping.
But you'd have to look at how well it matches up with the ones you have. So if it's like ideas, I have concepts.
Yeah.
You could put those concepts in. Or if there's somebody that wrote a book specifically in that area, could put the books in. So I see some possibilities there, but I'm not sure how everything would fit.
Well, what we might be able to do is you might be able to give attributes to your existing entities. And then those attributes could then be related to essentially to this additional meta model. Yeah. So if you've got structure as a concept within your existing model, which I'm sure you have, yeah, you could label that as a concept related to identity. Yeah.
I have to think about that more.
And the viable system model, you could label that as a theory of capability and purpose.
Yes. Now the way in, yeah, I do have, I have theories and principles.
Yeah.
Also.
Yeah. And that would be a fun exercise, deciding what's a theory and what's a principle.
Yeah.
Yes. Yeah, I went mostly by the names they actually had.
Yeah.
As opposed to how they're specifically defined.
Yeah. So that very act would help us to mature the structure of the model, because we'd be taking concrete stuff and seeing where it fits. Yeah.
Yeah.
And having those debates about, well, does it fit there, or does it fit there, or does it not fit anywhere? Those kind of conversations. And what I've always hoped is that over time that would get easier, and we also get new insight.
Yeah. Yeah, I would like to see it develop more towards ideas and away from simple things like people and books, although they're important. Yeah, the other one I think I mentioned was schools of thought. I have 5 or 6.
Great.
Yeah, it would be interesting to maybe pick 1 or 2 of your categories and see how that could be
Yeah, that would be a starting
implemented.
point. Yeah, this should be the easier end over here.
Yeah.
I think the circular model that fits with form, function, and fit. I guess I'd start there and populate the model that way.
Yeah.
And then you have all the hooks to bring all the other pieces in there.
Yeah.
So it's using that as the kind of, because you've got a lot of the headings on there that should line up with the matrix.
Yeah. Yeah.
And so that is kind of like putting one model at a time in, and then connecting the dots between the models and see what happens.
Yeah. Yeah.
But that one's a good one. The left-hand side of the matrix is a good one. They both relate together. And then you build the horizontal part and see how that plays together. And then we can see how all that fits with the other models you've layered on top of that.
Yeah.
That'd be my way of going about it.
Are you familiar with this one from Jack Ring, Tom?
With who?
Jack Ring.
Yes.
Yeah. So he's got the problem solution system. Yeah. So this is one of the models that is in the SEBOK. And what I realized was that there was again a correlation between this and fit, form, and function. Yeah. So focus on value. That's this top bit. This is the big picture for appreciation. So again, it relates to AIC as well. So appreciation is up here, Influence is here, which is focus on purpose. Yeah, and then you've got the system at the bottom. So the system itself in the context of the whole. Yeah, so fit, function, and form is here.
Mhm.
So now the question is that validating your circle model?
Yeah,
Or is that going to replace your circle model? Or how are you going to use these? I mean, that's just because I like both of them, but I think they may work, again, in different contexts. They may work fine.
yeah. Well, this is looking at essentially it's essentially the system engineering. It's the human activity system here of the engaging. This is the engaging with systems. Yeah, but underpinning this is this more general model of any. This is related to essentially any system anywhere. Yeah, so any system anywhere has a form. It's part of a whole, and its fitness is judged in the context of that whole, and its function is essentially a conversation between the part and the whole.
Yeah. So again, I see the one on the right, the circles being the system, a definition of the system, and the one on the left being the life cycle of how you engage with the system, basically.
Yes.
So, and I think those two elements, that's kind of how I saw the top horizontal row as being the life cycle of engagement, and the left-hand side on the vertical being the system.
Yeah.
So those two concepts, I absolutely agree, are quite powerful and quite important. Being clear on the system and the life cycle they go through. So,
Yeah.
And the other thing that comes up is that when you're doing a designed physical system, there's always a life cycle and an enabling system.
Yeah.
That makes it so you can't have a designed physical system appear without having some kind of human activity
Yes.
occurring.
Yeah.
That doesn't make any sense. So, and those are just different classes of systems. So a living person can, through various means, replicate other human beings. But I guess you have human activity there. But I guess it's, it's kind of every animal or cell has some way of replicating.
Yeah. See, what I'm thinking is, again, we can relate the powers to Jack's model. Not exactly sure of the placement yet, but
Yeah. Well, your ability to map all these things together is quite wonderful. And
crazy, you mean?
no, it's looking at patterns. There are patterns in all these things.
Yeah.
And the patterns are actually quite important. But it's trying to get to the fundamental patterns, which is what you're trying to do.
Yeah.
And I think that they're quite, it's
Interesting. Probably something like that. Yeah, something like that.
Yeah, great.
Well, that was fun. Yeah. We could, on this diagram, we can relate lens, because this is knowledge about systems, so we could relate lens, because Len has the equivalent of these as well. I don't know if you noticed that. I think it's on this presentation. Yeah, so these are lens system process theory. So he's clustered essentially nature's processes and nature's processes against these essentially rules of transformation. The rules of beginnings, of constancy, identity, of form, scale. I don't know if you come across lens work, but that could be related to this. This is nature's system, generalizing across everything, and this is the human activity system.
Yeah.
Okay, I think that's enough for now.
There's a lot of good stuff in there. So